Thank you everyone for joining, and good afternoon and welcome to the webinar on how semiconductor companies like Samsung are pioneering EDA in the cloud. My name is Aditi Sharma and I will be the moderator for the webinar this afternoon. I work as a Strategic Partnership Development Manager, and prior to Rescale, spent 11 years at Intel in a variety of R&D and engineering roles. My co-presenters today are Jeff Critton and Riaz Liaquat. Jeff is our EDA sales lead and comes from a 21-year career at Cadence Design Systems, where he led Cadence Cloud Business Development Team. Riaz Liaquat is our EDA specialist solution architect and was a wireless chip designer in the past life, and also worked as a senior application engineer at ANSYS. Let's take a quick look at our agenda for the hour. Jeff and I will kick us off with an overview of how electronic design automation is done on Rescale. And after that, we will hear from Riaz, who will walk us through a live demo of Rescale platform utilizing Mentor Graphics Calibre DRC. We will end our session with a quick Q&A. So we'll start off with a brief overview of Rescale. We pride ourselves as being the leader in cloud HPC, high performance computing, and also provide a turnkey full stack platform solution for all EDA needs in the cloud. Through our platform, users have access to over 600 industry standard software applications. On top of that, we also maintain multiple versions for each software, so we provide backward and forward compatibility. Rescale is not an IaaS, and we leverage the cloud infrastructure for all tier 1 cloud CSPs, providing the most cost-effective and comprehensive solutions for our customers. We serve 8 market segments from aerospace to semiconductor. We initially started with aerospace and automotive, but are rapidly expanding within the semiconductor vertical. We have a very cohesive partnership ecosystem across semiconductor vertical, from tool vendors to IP vendors, providing customers instant access to EDA tools to design chips end-to-end on our platform. Over here on the top right, provide a brief list of the partners we have. Our top vendors from Samsung to TSMC to Mentor, Cadence, and Synopsys, and ANSYS. We are venture-backed and headquartered in San Francisco, but have a global presence to support our customer needs across the globe. We are industry analyst endorsed and have technology partners from NVIDIA to AWS and all the main brands in this ecosystem. Next slide, and I'll hand it over to Jeff Critton from now.
Hi, good afternoon, folks. So the next slide talks a little bit about semiconductor design and why it was sort of late to the cloud party per se. So in semi-design, it's very complex. Not only do we have to have the software vendors embrace the cloud and let us host their software, we also have to have the whole ecosystem come on board. So the challenges there are people like the fabs of the world, the Samsungs, the TSMCs, and the global foundries. Then there's also the IP providers as well, if you want to use somebody's USB IP, for example. So getting the ecosystem all in place and ready for a designer to log into our platform and have everything ready to go. On security, we have the challenge of getting fab qualification and IP qualification to be hosted in the cloud. Rescale as a platform provider is the best in security around the globe. And we are happy to say we have the top 3 fabs around the world representing 80% of the world's silicon manufacturing capacity, endorsing Rescale and allowing us to host their PDKs on our platform. Finally, why do you want to use the cloud today? Well, with advanced nodes, 7 nanometers, 5 nanometers, if you look at the sign-off technology, the software vendors have done a great job creating software to parallelize up to thousands and thousands of cores. So you can take your full chip static timing analysis down from 6 or 7 days to 4 or 5 hours. So instead of waiting a week to get your results, you get the results same day. And then if you have to make a change, you're not waiting yet another week. So you can do a daily run of sign-off technologies, which is key to hitting your time to market goals. And so why do it now? Really, it's all about agility. Right? Without that agility, it's going to be very difficult to get closure on timing, IR analysis, and you need to hit that tape-out window, and it's only going to get harder and harder as you go to 7 and 5 nanometers. So if you think about the typical fabless semiconductor designer, what they're asking us for is a turnkey solution. They want a cloud where they can log into it. They want to be able to see their software there. They don't want to only see, for example, one vendor's software. They want to see everybody's software, so that's Cadence, Synopsys, Mentor, and others. They want an ecosystem with PDKs available, workflows that work out of the box. They want to log in and start their job, say, within the hour of initial login. They need security. They demand security. It has to be encrypted. They have to have multi-factor authentication. You know, if the fabs sign off on our security, you can be certain that the security is first class. The ability to control things like budget. So if you're the CFO of a company and you spend, a couple $1 million per year in your cloud spend, you want to know which project, which person, which group is using that money and how are they using it. You want to be able to control that cost. You can't run out of control. Agility. You're about to tape out and you find a problem. You need to be able to throw as much resources, compute resources at that problem as possible to hit that window. Because if you miss that window, it's going to be very costly from a market point of view. So if you think about the semiconductor design flow, where does cloud make most sense? In my opinion, if you look at the back-end design portion of the design flow, where you're doing tasks like DRC, LVS, static timing analysis, IR analysis, these tasks require large files. So you're sending a chip design database into a particular software application. You need a ton of memory. For instance, in STA, you're looking at servers that need 1 terabyte or 2 terabytes of RAM, which is something typically not available in your data center. And they're relatively sequential and clean tasks. So here, the cloud really adds a ton of value for multi-threaded memory-intensive workloads, like the ones we have listed above. And the great thing here is because these are not typically available servers in your data center, you can access these real time in the cloud and get your jobs up and running. On the front end portion of the design flow here, a lot of people will think about logic simulation, Verilog, VHDL, whatever. And the challenge here is most companies have been around for some time. They've created scripts, they've created custom executables, there's hard-coded paths. So the ability to take these workflows seamlessly up into the cloud sort of within the hour or within the same day is a little more challenging. So if you have a little time in your design cycle, you could spend probably a week or two on this process. And what you get here, instead of high-end servers, you get a lot of servers to parallelize all your runs to get to coverage goals quicker. So both areas are all about time to market. Here you're saving runtime because a single task is parallelized over thousands of cores. Over on this side, you're running thousands of jobs and you're just running them concurrently instead of sequentially. So both sides have a lot of value. Here, because the servers are not readily available, generally on-premise, it may make a little more sense to focus on the back end initially. So an example of this is our collaboration with Samsung with SAFE CDP. Rescale has partnered with Samsung Advanced Foundry Ecosystem, SAFE, and we've developed a cloud design platform for Samsung's fabless semiconductor customers to utilize in a multi-cloud, multi-vendor EDA flow on Rescale to deliver an entire design flow RTL to GDS2. The key things to think about here is multi-cloud and multi-vendor. So by using the Rescale platform, because we are agnostic to both industries on the cloud hardware side and the software side, you can pick and choose tools from your favorite vendor, whether that be Synopsys, Cadence, or Mentor. And depending on the compute availability within a particular cloud provider, you can go to Amazon, you can go to Google, you can go to Azure as well. So you have options on both sides there. And what does that mean to you? So we worked with Samsung's customer Guion chips, and they showed a 30% increase in efficiency, meaning a 30% better time to market by using cloud for a 14 nanometer automotive chip design. So real results, meaningful. This can shave, a month off your cycle overall. Plus. So how does the system work from a high level point of view? What we have here is you log into Rescale. You're going to see software applications from Ansys, Cadence, Keysight, MathWorks, Mentor, Synopsys. And this is very EDA centric. I think we have we have hundreds of applications available within the system. And we supply the sort of integrated stack of deployment tools for the cloud. You come in, you provide us your input data. You select the software you're going to run. You may upload a shell script to run that software. Then you provision your hardware settings here based on the cloud provider of choice. And you can see down here support of Amazon, Microsoft, Google Cloud, Dell, Oracle, and HP. And then away you go. You upload your PDK because you're going to be working with one of the fabs, and we do support the top 3 in the world. And then you do your runs, and you either pull the data back or you post-process in the cloud. And literally, it's within 10 mouse clicks, you're off to the races and running. So I talked a little bit about the ecosystems, and the key thing here is getting everybody together, the EDA vendors, the foundries, and the IP vendors, and also the hardware providers into one seamless environment so you can upload your data and be effective in running applications in the infinite capacity of the cloud is a non-trivial exercise. And today, Rescale is the only commercial provider that can bring all these people together in a seamless environment and enable you to access the cloud quickly and efficiently. In fact, we are a partner of Cadence's Passport Partner Program, and we're also working with the other EDA vendors as well. So this whole bringing everybody together really creates a very highly differentiated value chain that can only be accessed by the Rescale platform. So a lot of people will ask me, so why don't we just build this ourselves? Well, a couple of things. Rescale's been around since 2011. We've invested close to $30 million in building the Rescale Scale X platform. That represents just over 150 man years of engineering effort. And so why use a commercial platform in the first place? So if you want to work with different cloud providers, you're going to have to sit down with them all. You're going to have to negotiate discounts. You're going to have to negotiate access. With Rescale, we've done all that work for you, and we're natively multi-cloud. So at the time you submit your job, you can select any of the cloud providers we support, and we support all the major cloud providers in the world. Number two is all the applications we have installed on our platform, we have preloaded workflows that work out of the box. All you have to upload is sort of your shell script to launch the tool, and you're good to go. Here, you'd have to create your own cloud environment. You have to install all your software. You'd have to have an IT or CAD department full-time working on this to make sure this is always up to date, creating new versions of the software and new access to different versions, etc. Number three, here we talk a little bit about engineering controls. So this is really important on the budgeting aspect. So your company is putting money into using cloud, and this is not a non-trivial expense. They're going to want to know who's using it, what are they using it for, how much are they using, is there control such that somebody doesn't launch a job that spins there and runs for thousands of hours and you get a bill for nothing. So all these controls are super important to ensure that you're getting return on investment for your cloud spend. And those are all built into the Rescale Scale X platform with something we call Insights. And finally, all the tools, versions will change over time. They'll need to be updated. So the big difference is a lot of custom work here, expense versus out of the box and ready to go. There's a study done by IDC that says for every dollar invested in high performance computing, the incremental revenue seen by the company investing in HPC is $463 and incremental profit $44. So the return on investment here is just unbelievable. The challenge here is, though, of those companies making those investments, only 72% were able to achieve any type of ROI because the rest failed in their deployment of HPC, which is a great reason why you'd like to use a cloud provider and access HPC in the cloud instead of on-premise. Your IT guys simply can't predict the type of high-performance computing you're going to need when you hit that crisis come tape out. So I talked a little bit about controls. So here's an example of a dashboard. We have dashboards all across the different types of usage models in the system. So here we're looking at a example company called Acme Group. They have a number of workspaces that we've created. There's a number of employees accessing each workspace. They use 11 different software applications that are specific to them. They're allowing their engineers to access 19 different types of hardware. So they have 81 members accessing all the different projects and doing design. And what we have here, we have different administration, different admins organizing the system. So what you can do here, you can quickly look at how many members are in a given workspace, what type of software they're using. You can also look at different expenses. So how much did this particular project spend on cloud? Are they on budget, over budget? You can empower the system to sort of stop them spending money if they go over budget. Same thing down for this other workspace. All the data can be taken off in Excel and you can slice and dice it whatever you want. So you get full visibility, real time, across the board for any kind of aspect of your cloud usage.
Thank you, Jeff. I think we'll move into the next section of our webinar today, where Riaz would walk us through a deeper dive into the demo of the Rescale platform.
Awesome. Thanks, Aditi and Jeff. Good afternoon, folks. My name is Riaz Liaquat. I lead all our solutions efforts for the EDA engagements at Rescale. Over the next 30 minutes, I want to talk about what are the different architectural and product features that we have at the Rescale platform, which is relevant for EDA. And the second part, I want to focus on a live demo where we'd be running an EDA workload. In this case, we'll be doing a DRC analysis on the Rescale platform. And I want to walk you through all the different steps. So let's first talk about our platform stack and what are the different pieces that is relevant here. First, as Rescale is built on top of this API. Our platform can be accessed through a web UI. You could also touch our platform through a CLI, or a lot of the EDA workloads can be automated to API. So essentially, you could create like a job submission script, which lets you upload input files and then pull data from your storage, run the job, and then download the data back. Right? That whole piece could be orchestrated and automated. If we look at the stacks that is important for EDA, I would say like there are three main pieces, right? The first is the application stack. So here on a Rescale platform itself, we have close to 600 plus applications onboarded and ready to go. And with respect to EDA, so we work closely with all the major EDA vendors in the space, Ansys, Cadence, Mentor, Synopsys, and Keysight. We work with them on a continuous basis to make sure that all the latest software is onboarded on the platform and is easily available for the customers. And on top of that, we also have Stack where you could also do some ML analysis, like if you want to do like a regression analysis using TensorFlow, or build your own containers. So we also have features which enable that as well. So in a sense, like we can onboard an application and then manage it for you, or we also let you bring your own application and then start running the workloads across any cloud service provider. The second piece that I want to focus about is the infrastructure automation. So this I think is very difficult if you want to run the workload directly on the cloud. In the sense, like there are many pieces that we want to automate here. So all these challenges is solved through the Rescale platform, and we have APIs which does the orchestration. So on the back end, we make sure that when you launch a job, we are able to launch it across like any cloud service provider. And then we have intelligent algorithms which make sure that the jobs are launched reliably and they're also like completed. When you are launching jobs, we also have like intelligent algorithms which use machine learning to come up with different types of mechanisms where you can submit the jobs using the spot market and run the jobs in a cost effective manner. We also have the other pieces, like in the EDA space, it's mostly bring your own license. So if you have your own license, so you could host that license on Rescale and then use it for running jobs on both Rescale as well as on-prem. Or what we could do is if you want us to connect your on-prem license server, so we also have like a robust multi-cloud VPN solution where we are able to connect to your on-prem license server and then use those licenses. The other pieces like networking and security, so all these are automated through our platform. So from a user perspective, so you don't really have to worry about, hey, am I using the correct IAM or am I using the right security group? All these pieces are actually managed by us. So it removes the burden from the user. And in terms of monitoring, we'll talk about it but essentially like when you are running jobs, there are features in place which lets you monitor a live running job. You could do it for a batch job, or for certain workloads, you might want to open it interactively and see how the job is running, right? So we do support both the different options. In terms of the job architecture itself, like Jeff was talking about, at a high level, there are two pieces, the front-end design and the back-end design. And if we actually break down in terms of the compute, so we have like a certain set of workloads which are computationally intensive. And then we have another set of workloads which is memory intensive, right? So you want to be able to have flexibility across like, different types of VM, which can run for compute intensive workloads, embarrassingly parallel workloads, or like you might also want to run a huge time, physical verification analysis, right? Let's say, now I want a 1 terabyte machine. So certainly we have close to 52 different architectures on our platform. And that gives our customers a great deal of flexibility to pick and choose any type of hardware to run their workloads. And when we are running these workloads, an important piece here is, hey, how do you manage my process design kits, right? Like how do I host it? So we certainly have developed features specifically addressing this challenge. So we have like persistent block storage, where you can run, where it's running an NFS filer system. So essentially you can spin up like a shared node, put all your PDKs in, and then create your simulation environment so that you are able to run, any type of workloads, like whether it's LVS or DRC or SPI simulation. So that part is handled through our, persistent block storage. And the last piece I want to talk about is also visualization. I think like this is very important. So historically, when we started cloud, we are always, thinking about like batch workloads. But as we continue to evolve in this journey, so we also understand like there are like certain workloads where you might want to, after running the job in batch, open an interactive session and then perform a quick analysis. So on our platform, we do have like advanced VDI solutions. So using like nice CCV, which provides low latency, high performance visualization. So in this demo, I want to focus on a use case so that it gives everyone an example to see how this is set up, right? So in this, the use case that we have in mind is DRC, design rule checking. So if we talk to our customers and if we say, hey, like what are your most compute intensive workloads? DRC is one which comes in the top three. It's because if we actually run DRC for the latest generations of the chips, so some of these analysis could take a day, a couple of days, to even like weeks, right? So this adds a huge bottleneck in the design process. The question is, how do we solve this process so that we can cut down the design cycle and increase your time to market? So that's exactly the challenge that we are addressing here. And I want to talk about like the architecture of how we are going to run a DRC on the Rescale platform, right? So I'd say like there are three important pieces. The first is the high performance storage. So this is the block storage that I was talking about. So it's an NFS mount shared storage where you can bring in your PDKs, your GDS files, your OSS files, and all this, and you can essentially set up your simulation environment. Now, once your simulation environment is set up, you can run many jobs against it, right? You can run like concurrent jobs. Or multiple users can also pull data from this and start running their own workloads as well. So this is the first step. The second step is running Calibre DRC itself. So here, the most efficient way of doing this is to run this in batch. So essentially, like you bring in your a user would do all your pre-processing. You build your layout on-prem, and then you bring your GDS or your OSS file, and then for each process, there is a set of rules that you need to validate against. That's exactly what we are doing with DRC, right? So you're saying that, hey, this is my layout, and I want to run this against this set of rules to make sure that I'm not violating any process, right? So essentially, you bring your your layout files and your rules files, and then here like you can run Calibre DRC. Now this process can depending on your problem, it can be right size, right? So you can either run this across multiple cores of a node, or if you have like really large model, then you could also use like multiple nodes and scale. So this running this using the infinite capacity of cloud solves a key bottleneck. So once this DRC is completed, let's say I go and review my results, right? So once the DRC is completed, it generates a bunch of ASCII or database files. And then I find out, hey, like, there are certain, layers which are violating DRC. So how do I now check and correlate this with my layout? So instead of actually pulling the ASCII files back and then doing it on-prem, on the Rescale platform, since you have like advanced VDA solutions, so what you could do is you could open a design rev and you can open RVE, where now you can pull in your results database and then interactively check which regions are like passing or failing DRC, right? Depending on like how severe it is, like you can either waive off that that particular rule, or like you can also continue to refine your layout till the point that you're able to pass your DRC. So just to recap, right? So we have three steps here. The first is we set up a high performance storage. The second step is we run Calibre DRC in batch. And the third step is layout verification or debugging using Mentor RVE. So let's actually investigate a real scenario. Let's assume that I'm a designer. I came up with a layout design, and I have like three sets of design, right? The first set of design is where I made sure my design is pretty conservative. So I know that this will pretty much pass DRC, but I want to make sure that running Calibre if this is actually compliant. The second and the third set of designs, which I call it as layout B and layout C. So I've made some changes to this layout. The second one I made like metal one width thicker, and this is to improve the performance, right? So if I want to improve performance, so obviously there are different aspects in my layout that I can tweak to be a bit aggressive. So in the second design, I've increased the metal one width, and in the third design, I've also modified a couple of layers. So in this case, I modified like poly 4 layer, and essentially I made the gate edge higher. So these are my 3 sets of design. So I'm curious now, if I run DRC, like which one is going to pass and which ones are going to fail. And if it fails, like how do I go ahead and debug it, right? So that's the scenario. And let's jump into our platform to see how we can do this. So I'm currently logged into the Rescale platform. We can log to the Rescale platform through a web UI, but we also support programmatic access. So anything that you see here, like me launching a job or standing up a storage device, everything can be done through a programmatic access. So here, the first step I want to do is I want to talk about how you can spin up a high performance storage or a storage device, right? So let's actually walk through the steps here. So let's give this storage device a name. And then the beauty about building these storage devices on Rescale is depending on the type of storage requirement that you want. So you can always build your HPS devices, right? So you could say that, hey, you know what, I'm interested in a 500 gig shared storage. And once you build the device, you also have flexibility to increase the storage as well, right? So you could say that, you know what, I built a 2 terabyte storage, but I see that 80% of that is getting filled. So I want to extend it by 1 terabyte. As a user, you certainly have functionalities to do it. So you could also set up some intelligent options such as, auto extending, which will automatically increase the disk storage once it hits 90% capacity. So you can build your storage device, and then you can also set up notifications when you could say that, hey, you know what, notify me once every day, or like send me a notification when it is at 60%. So what all these does is, as an administrator, when you're managing all the shared storage, which is essentially like a NetApp in the cloud, right? So one, you are able to get very detailed information of what's actually going on with your storage. And then like you're able to, let's say that you get an email saying that your storage device is 90% full, then you are able to act on that insight, right? So you're able to, it's very actionable insight that we provide to the user. So once you provide all this information, what you could do is you could just simply submit this node. It takes about a couple of minutes for this node to launch. So in the interest of time and the demo, so what I've done is I've already set up an environment which is relevant for our demo today. So here, if once the node is up and running, since it's using NFS file system, so you could always create like a directory structure, like how you have it on-prem. So I could create, different types of directories, and I could put like whatever files that I need relevant for that workload. So in this example, so what we are going to do is, so I've already run 2 tests. So I've done the design layout A, and then I've created a bunch of output results. I've also completed layout B as well, right? So I have like 2 sets of data. So now what I want to do is I want to see how I can run layout C. And once I have that layout C data, then we are going to pull everything into RV and then do like a post-processing, right? As I continue to work on this, I want to show you a couple of things. The first thing is, so whatever we are doing here, you could always SSH into the node. So if you actually go back to my storage device, so once you set up your private and public key, you could always SSH into this node. And once you are SSH in, then you could, essentially like, I can list all the folders, and I can see like what is inside my different folders. Or if you want, like I can also like ACP additional files as well, right? So that's an easy way to do it. We could also do this through the UI, which I'm going to show you today. So what I can do is, hey, I'm going to say that, I want to create another folder to upload all the files relevant to my C design. And then after that, I'm going to start running my DRC match. So let's go ahead and create a folder. So let's call this So you can see that now we have created a folder. So you can now HTTP files into this folder, or you could also say that, hey, you know what, I want to upload directly from my computer. So we can certainly do it. And the way is like, once you click on that, you have an option to go and pick whatever file is relevant for you. So in this case, I want to pick all the files relevant to the C design. So I want to say that, you know what, pick all these C files, right? And if I'm looking here, so I have my DRC rule set, which is going to be standard across all the design. I had my third variant of the design, and I have my layering input files. So once I do this, we upload the data on the Rescale platform, and then we have it available, right? So we are good. So we have our third design, we have all our input files. Now let's go back to step 2. So we have completed step 1, where we have created a storage device. Now let's talk about, how you can actually use that input file to run a Caliber job, right? So in order for you to run a job on Rescale, it's very simple and straightforward. So all you need to do is you need your input file, which we are going to pull from our storage device. You choose your software of interest. So you have for EDA, we have close to all the software from Access, Cadence, Mentor, Synopsys available. In this case, you are going to be picking the RC. And then the hardware settings is where you decide on what type of node that you want to run this job on. So based on working with us, we have run many benchmarks for the EDA workloads, and we can provide guidance on what workload is best to run your job. And eventually, we are also building this intelligence into the platform so that at some point when you choose the application, you'll automatically be prompted with the correct hardware recommendation. So let's give this job a name. I'm going to call it layout. And here, what I'm going to do is I'm going to attach pull input files from my storage device. I'm going to say that, hey, you know what? I want to use my shared drive. And what I'm going to do is you can connect your files via symlinking, or you can also copy the files. But here, what I'm going to do is I'm just going to mount the storage device to my compute cluster, and then eventually pull the data from there. I'm going to say that, add the shared storage. The next step here is choosing the application. So on your Rescale platform, we have many applications. So in this case, I'm actually interested in Caliber DRC. So I choose Caliber DRC. And once you choose the application, so you can also choose the versions of interest. When we onboard a version on the platform, so we don't deprecate any old versions. So within a single click of a button, you can actually go between multiple versions. This, I think, is especially relevant for EDA because when we see customers start a project, they want to stick to that version of the software, right? So you could always pick the version, whatever is relevant for your project. So in this example, I'm actually going to be using this version. And once you pull a software, you can see that the command line is automatically populated. So there are just a couple of things that we need to do here just to make sure that we are mounting a storage device. So we need to specify where the file is living, right? So we could do something like, here is CD. And then I need to know what is my storage device, right? So storage device, I can easily pull from here. And then I need the name of the folder. So I could also do this. So I can open this in another tab. So I can see that, so this should be my location. So I can say go to this location. And from there, so once we are in that location, I think we are good. From there, like it's automatically going to pull the DRC rules file. So the command line is, we don't necessarily want remote option for here. So we are just going to run this model with 4 cores. So hyper should be good. And once, so we have that, the next thing is we need to know what is the name of our rules file. So you can again go here. So pull this information. And paste it. And then I could also say that, dump all this information into a log file. So you could also write like a DRC log file. So that's kind of, that's pretty much it, right? And this command line can also be, if this is a repeatable command line, so this can also be automated, where we can create like custom command lines and have it private for your version. So next step is choosing the license. So with EDA, it's going to be mostly BYOL. So you could always point to your license server. So in this case, I'm actually going to point to a license which is hosted on our platform. So I could point to that. And once I do this, so then I move on to the next step. So next step is choosing the hardware. So here you can see that on our Rescale platform, we have plenty of options available depending on the workload. So if you have a workload which requires like, high clock speed, like if you're just running an application which is single core, so those would definitely benefit from high clock speed. So if you're running a large, verification application where you need like high memory, certainly we have like, high memory core types. For this particular design, it's actually not a very big model, so I'm just going to use a general purpose core type, Emerald, which we've seen it to be like very good for EDA workloads. So I'm going to choose that, and I'm going to run this with 4 cores, right? So let's go ahead and give this, submit this job. So once you submit it, it's going to take a few minutes to stand up the cluster, and once the cluster is up, the job is automatically going to get executed. So to recap, right? So far you've seen like how we created a storage device. We launched a batch job. So while this job is running, I want to go to step 3, where we are going to create, we are going to open Mentor Design Drive and RV in an interactive session, and then start pulling these database files so that we can do some verification, right? So let's actually go to step 3. So in order for you to launch an interactive session, the process is very similar to how you did batch job. So I actually have an interactive session which is already running. So the only difference is instead of running Calibre DRC in batch, you would say interactive workflow, and also the job type instead of like batch, you would pick like end-to-end desktop, right? So once you do both of these things, so what's happening is after the job is completed, so we are attaching a VDI to the head node where you can connect interactively to an in-browser desktop, or if you have your own favorite VNC remote viewer, so you could also use that. So that's kind of what I'm going to do in this demo. So here, my expectation is I launched a Calibre DRC interactive workflow, which contains like design rev and RV. So I want to log into this node and open them interactively, right? So I could actually go ahead and do that. So I have my localhost file, and once I log into my VNC, so you can see that we are inside the inside this compute cluster, right? So we could say, so currently we should be in the shared directory. All our files are located with this storage device. So what we could do is we could say, hey, let's go into the storage device and find out like what are the files which are located. So we see everything that we have created, right? So we have our layout A, layout B, and the layout C, which we are currently running. So now let's try to start RV and start our analysis at least with layout A and B while we are waiting for the data from C, right? So in order for us to do that, the next step is for us to launch RVE. So let me cd to this location. So here, if I look at what are the files available in this folder, so I have this log file from my run. So I could do cat drc log, and then so this shows that so this design was completed and everything was executed, right? The things that are important here is after this job is completed, so Caliber DRC throws out this RDB or the ASCII file, which is what we need to import into RV to do real-time analysis, right? So let's actually go ahead and open Caliber Design Dev. So I could say Caliber DRV, and then I could say open it with my design, right? So full chip, that's the design file that I want to open. So once you do this, so it usually takes about like a minute for you to load this input file. And in the interest of time, so I also have a version which is currently running, right? So let's minimize this. So basically you will have your design drive open. And now what you could do is you could say that, hey, you know what, I want to load the layout, right? So I want to load the layout for layout A. And I could say that this is my first design file. So I'm going to say load that. So you can see that, I have my whole design, beautifully displayed. And now once I have my layout, I could open RV to do some real-time debugging and analysis, right? So I could say go to verification. And by the way, you could also run Caliber DRC interactively as well. So you could say like go and we can start RV. I actually have another session which is running, so we could reuse that. So we have RVE, and now what we could do is we could say open database, right? So I'm going to open the database which is relevant for design A. So I have my design 1, and then I have my ASCII files from my Caliber run. So this shows the results for design A. So to recap, right? So we had like 3 designs. I was pretty confident that the first design would pass because it was a very conservative design. So I'm actually like not surprised with the results. So you can see that almost all of my layout passes CRC, right? The first 2 are just like off-grid vertexes, like which we can ignore. But I'm more interested in trying to, pull in data for like design B and design C, because those are the aggressive designs that I have, right? So let's actually do that. So let's close this layout. We could also close this database. So I could say open layout, and then I can say, now we looked at A, let's go to layout B, right? So this is going to be my second and aggressive design. So I'm going to pick that. I have that, and then I could also say load the corresponding database, right? So I'm going to go to layout 2. So here, let's look at this, right? So I can see that I'm failing DRC for quite a few layers here, a couple of polygon layers. And then I was kind of expecting this for metal 1 because my metal 1 width was slightly thicker than what was defined by the process. So I can actually pull this information. So I could say that show all the unresolved. And now when I click on metal 1, what the nice thing about this interactive flow is I could actually go and point in the layout where is the actual issue. So I could say there are 2 versions of RV. So let's actually pull this one. So I could actually say that, these are the areas that is failing DRC. Now, what this tells me as a designer is, hey, these layouts are failing DRC, and then I have to go and fix them. So you can either fix it directly on Rescale and then continue running additional DRC. And this is an iterative process, right? So eventually you'll have a design which passes DRC, and then you can move on to the next stage. Or you could also say that I think these violations are okay, and then I'm okay to move forward, right? So you as a designer are empowered to make those decisions. Now, what the value here is, instead of pulling this database file back to on-prem and then loading another version of Mentor separately, we're able to do this entire workflow on cloud, and that's the tremendous value that we provide. So with that, let's actually go and check if our third design is also running. So you can see that the third layout has also started executing. It usually takes like 5 to 7 minutes for us to complete this. But what I also have is I have a version of this design which is already completed, and we can use that for verification now as well. So if I actually go back to my Files tab, so I have a version of the C design which is already completed. Let's try to open this design to understand now how is this design doing, right? So let's go back to our VNC viewer. So I could say close this database and also close this layout. This one's currently running, so I could go here, and then this is my third design. And then I can open the relevant database for that. Okay, so here we can see that this design is at least better than the second design. It's just like one layer is failing, and after talking with your process engineering team, you could decide whether this is something that you need to pay attention to fix in the layout, or if this is something that you could just skip. And you could always go back and find in the layout what are those designs, what are those polygons that needs to be fixed. Well, that's pretty much what I wanted to show in the demo. So to summarize, what we saw today was how you can run Calibre DRC end-to-end on Rescale platform. So it contains 3 pieces, right? So first is you spin up a storage device to set up your environment. Then you can run many batch DRC analysis for different cases. And then once you have all the batch analysis database, then you can open RV interactively and then look in real time to identify where is the error, and then fix those errors to continue in your design process. That's pretty much it. Over to you, Aditi.
Thank you so much, Riaz, for the very in-depth demo. We'll get into Q&A now. We got a few questions. Let me start off with the first one. Jeff, I'll pass this on to you. There's a question about, can you please talk a little bit about the pricing of the platform?
Sure thing. So pricing is basically fairly simple. There's no software or licensing fees or no software license maintenance agreement required. You essentially put a deposit into a Rescale account, and that goes to fund your compute costs. And we increase the compute costs basically by a few pennies per compute cost per hour. And we, instead of rounding by the hour, we go down to the second. So you're only charged based on how many seconds of compute you use. So the business model is very simple. A minimum deposit on an annual basis, and then that is debited against the compute that you use every second.
Thanks a lot, Jeff. So we cut out a little bit at the end, but it's just like Jeff said, pay-as-you-go model based on second billing. Next question, I think, Riaz, you talked a little bit about storage, Could you talk a little bit more about how do customers have access to large Foundry PDK or design library files on Rescale?
Yeah, no, that's a great question, and that's actually a very important question when we think about running EDA workloads, right? Because it's not just your input file; it's actually how do you actually bring your PDK data and then use it to run the jobs on the Rescale platform. So we have like two solutions. So one from a partnership perspective, and the other from a technical perspective. So from the partnership perspective, we work with all the major Foundry vendors, like Samsung Foundry has built a platform with us, so you can easily get access to the PDK data. We also have close partnership with TSMC and Global Foundries. So essentially, we went through security checks and you're able to bring that PDKs legally to our platform. The second thing is from a solutioning perspective, the high performance storage or the storage device, which actually went over in the demo. So that will be the relevant feature here. So essentially, you can spin up like a shared NFS mount storage, and then you can also right size the storage device based on your requirement. But here, like you can host your PDKs and then use it to launch jobs on both Rescale, and you can also get access to that PDK for running on-prem as well. Now you could also, if you want to set up something more advanced, you could also have a local version of the PDK on-prem, and then you can set up like an rsync process so that your PDK is updated from time to time. Hopefully that answers your question.
Yep, thank you so much, Riaz. That was super helpful. The next question, maybe Riaz, if you could, I'll punt this over to you as well. Can I port my design from AWS to Microsoft Azure seamlessly without much engineering effort on the final customer or my end?
Great question. Absolutely. Rescale, one of our main value prop is we are a truly multi-cloud solution, right? So depending on the type of hardware that you choose, you can easily port your jobs from any cloud service provider, right? So if you are selecting like a core type such as Emerald, you are probably running on AWS. But if you chose a different core type such as Mercury, then you are running those jobs on Azure. So within a single click of a button, you can seamlessly switch between cloud service providers, and you don't necessarily have to worry about all the complexity in the backend, such as setting up your IAM, networking, and so on, because all those things are taken care by the Rescale platform, and we just provide a turnkey solution for you to take advantage of.
Awesome, thank you, Riaz. We'll take one more question in interest of time, and Jeff, appreciate if you could help answer that. What kind of support from different foundries can we expect on Rescale?
So on the foundry support, I think in the slides we mentioned we support the top 3 foundries in the world. And so clearly we all know who number 1 is in Taiwan, and Samsung is public about it. And the third one is a US-based fab. I'm not allowed to name them specifically, the ones that are not public, but it's fairly easy to figure that out.
All right. I think with that, we've come to the top of the hour. Thank you, everyone, for joining. Appreciate your time. If you have any follow-up questions, please reach out, and we'd be more than happy to help with any additional questions. Thanks.